problems on matrix using Cayley-Hamilton theorem. Okay, the question is, find the eigenvalues and verify the Cayley-Hamilton theorem, and also compute A inverse for the matrix A equal to 2, 3, minus 1, 4. The first row consists of 2 and 3. The second row consists of minus 1 and 4. Now find the, first of all, we have to find the eigenvalues for the given matrix. Let A equal to 2, 3, minus 1, 4. To find the eigenvalues, we have to know the characteristic equation. So the characteristic equation is determinant of A minus lambda I equal to 0. This implies lambda square minus trace of A into lambda plus determinant of A equal to 0. Now lambda square minus trace of A. Trace of A is nothing but adding the diagonal elements 2 and 4. So 2 plus 4 is 6 lambda plus determinant of A. The determinant of A is nothing but is equal to 2 4s are 8 minus of minus 3. So 8 plus 3 is 11. So determinant of A is 11 equal to 0. Now we have to compute the characteristic values using this characteristic equation. The characteristic equation is lambda square minus 6 lambda plus 11 equal to 0. By using the second degree quadratic formula, minus b plus or minus b square minus 4ac by 2a, we can compute the characteristic values. Here, the coefficient of lambda square is a equal to 1, and the coefficient of lambda is b equal to 6. The constant is 11. Now apply this quadratic formula. Minus into minus of minus 6 plus or minus b square. B square means 6 square minus 4 into a into c, whole thing divided by 2 into a. Now minus into minus plus 6 plus or minus square root of 36 minus 4 ones are 4, 4 ones are 44. Whole thing divided by 2 into 1. Now 6 plus or minus 36 minus 44. 36 minus 44. What is 36 minus 44? Minus 8. Whole thing divided by 2. Now these can be simplified into 6 plus or minus I into square root of 8 whole thing divided by 2. Now 6 plus or minus I into square root of 2 into 4 whole thing divided by 2. Now again further simplified into square root of 2 into root 2 whole thing divided by 2. You can take 2 on denominator divided by 2. Finally, we get 3 plus or minus root 2. The eigenvalues, that is characteristic values, lambda 1 equal to 3 plus I into root 2 and lambda 2 equal to 3 minus I into root 2. These are the characteristic values. Now we have to compute the Cayley-Hamilton theorem. Let A equal to, for given matrix is A equal to 2, 3, minus 1, 4. The characteristic equation is the characteristic equation. Characteristic equation is lambda square minus 6 lambda plus 11 equal to 0. By Cayley-Hamilton theorem, by Cayley-Hamilton theorem, this characteristic equation becomes a square minus 6a plus 11I equal to 0. To prove this Cayley-Hamilton theorem, now compute a square. A square equal to a into a. Is equal to, our matrix is 2, 3, minus 1, 4. Then next one, 2, 3, minus 1, 4. Now multiply these two matrices, we get first row and first column. 2 2s are 4. 3 into minus 1, minus 3. Right. First row, second column. 2 3s are 6. 3 4s are 12. Then next, second row, first column. Minus 1 into 2, minus 2. Minus 1 into 4, minus 2. Minus 1 into 3, minus 3. 4 4s are 16. Plus 16. A into a square. Now we get 4 minus 3, 1. 6 plus 12, 18. Minus 6, again 13. This is a square. We have to substitute this a square in this equation number 2. This is equation number 1 and this is equation number 2. So a square becomes 186 minus 6, 13. 118 minus 6, 13. So a square becomes, equation number 2 implies 118 minus 6, 13. This is a square minus 6 into a. 6 into our a is, what is our a? 2 3 minus 1 4. 2 3 minus 1 4. 2 3 minus 1 4. Then finally 11 into I. I is nothing but second degree equation. 2 by 2 matrix, identity matrix. Now simplify this equation. 118 minus 6, 13 becomes 6 into 2, 12. 6 3s are 18. 6 into minus 1 minus 6, 6 4s are 24. 11 0 0 11. Final result is 1 minus 12 minus 11, 1 and minus 12 minus 11, minus 11 into plus 11, 0. 18 minus 18, 0. Minus 6 and minus into minus plus 6, it becomes 0. 13 minus 24 is minus 13, minus 11. Minus 11 is plus 11, 0. Now the Cayley-Hamilton finally verified. Using this Cayley-Hamilton equation, compute A inverse. How to compute A inverse? Let us take the equation number 2. The equation number 2 is a square minus 6 into a plus 11 into e equal to 0. This equation into A inverse. Multiply this equation into A inverse. So A square into A inverse minus 6a into A inverse plus 11I into A inverse is equal to 0. This equation becomes A square into A inverse A minus 6 into A inverse I plus 11 into A inverse. On this equation, we have left hand side A inverse. So take this A inverse, keep the A inverse on left hand side. Otherwise, all the other elements goes to right hand side. So A minus A minus 6i plus 11a inverse plus 11a inverse is equal to 0. This equation becomes 11a inverse is equal to 6i minus a. Finally, a inverse equal to 6i minus a. A inverse equal to 6 into counting divided by 1 divided by 11. Now, a inverse equal to 1 divided by 11, 6 into I. I is nothing but 2 by 2 identity matrix minus A. A is our given matrix 2, 3, minus 1, 4. So finally, A inverse becomes 6 minus 2, 4, minus 3, plus 1, 6 minus 4 is 2. This is our A inverse. This is our